Hi, today in lesson unit and dimension we will take some topics, and the first topic is supplementary units. So let me take the ratio of circumference of a circle and its radius. And we know that circumference of a circle is 2 pi r. So when you divide, let me delete this. When you divide circumference by its radius, you get a constant value, you can see. And so for any angle, a part of circle subtending at the center, any angle which is in radian, here theta is in radian, the ratio of this length of arc and radius will be a constant, and that constant is equal to angle inside it. Here you can see the ratio is equal to angle subtended by whole circle, pi plus pi, 2 pi. So in this way we can define radian. What is radian? It is unit of angle, and this angle is made on a plane surface, so this angle is called plane angle. What is plane angle? The angle subtended by the length of an arc. And this arc is a part of a circle at its center, and this is taken in radian, Okay, and this is equal to the length of arc divided by its radius. Okay, so suppose you have a theta angle in radian, length of arc is equal to S, and R is equal to radius. Then theta is equal to, okay, let me do in detail. Then angle, plane angle, is equal to length of arc divided by radius. It implies that theta is equal to S upon R. So this is your plane angle, and its unit is here plane angle theta, and its unit is radian. Now next one is solid angle. If you consider a sphere like a ball, so it has some surface area, and we know that surface area of sphere is equal to 4 pi r square. And if you divide this by radius square, then you find a constant value in radian, 4 pi. This 4 pi is complete angle made inside at the center by this sphere. So from here you can find that if you take a small part of this sphere, small surface of this sphere or surface area del S, and it also subtends certain angle at the center. That angle is called solid angle. And you can see that this is not made on the surface of a plane. It is made in 3 dimensions. So this is called solid angle. Three-dimensional. Solid angle is termed by sigma. Its symbol is sigma. Okay. So solid angle is area of the part of a sphere divided by the square of radius. Therefore, sigma is equal to 4 pi. Okay, here I have taken surface area del S. Del S upon R square, and it is written in terms of unit steradian. And in short, you can also write ST radian. Okay, so these are supplementary units along with 7 basic fundamental physical quantities and their units. You have hundreds of derived units, and with those you have these 2 supplementary units also. This helps in calculation. All you have these number of units. So now next topic is advantages of using SI unit. These system of units are coherent. Coherent means advantages of SI unit. It is very advantageous. First one is it is coherent. Yes, every derived unit can be easily obtained by multiplying or dividing certain sets of basic units. Like you can find very easily the unit of volume, unit of area, unit of force by multiplying or dividing certain sets of basic units. Now second one, rational. It is very rational because in this SI system of units you use only one unit for some kind of quantity. Like for energy you use only joule. But in other system, like in MKS system or in CGS system, you use more than one unit for the same physical quantity, that is energy. For heat energy, you use calorie. For mechanical energy, you use joule. Okay, so it is just increasing the number of units and just making the things complicated. So SI system is advantageous in this way that it gives only one unit for one kind of physical quantity. Now it is based on metric system. Every unit, every multiple and submultiple can be obtained by in terms of certain power of 10. Suppose you have the things in centimeter, 10 centimeter. It can be very easily converted into SI system by multiplying with 10 power minus 2. Certain exponent of base 10. So it can be converted into a value in SI system. So it is very convenient in this way that any unit can be converted from its multiple and submultiple by multiplying certain power of 10 with that multiple or submultiple. Now it is advantageous, it is universally accepted. So these are the things why SI system of unit is very advantageous. Now next topic is to represent any number, any measurement in scientific method. Now, to represent any number, any measurement in scientific method, scientific way. We have to measure very small magnitude as well as very large magnitudes. Like, if you exactly measure the velocity of light, you will find that it is equal to 299,792,458 meter per second. This is your velocity of light. And this is how the other measurements, like measurement of mass of electron, mass of proton, large lengths, small magnitudes, they all are found in such a large value. So it is in terms of 1,000 million, 299 million, and it is very inconvenient to remember such a large number. So we represent it in a scientific method in this way: A into X upon B. If you represent this number in this way, such that it comes in between 1 and 10, and B is any integer. Then such representation is called scientific representation of any measurement, any number. Now let us represent this in this way. So let me keep A in between 1 and 10. So here let us go on reducing its value 1 decimal point, 2, 3, 4 in this number. 1, 2, 3, 4, 5, 6, 7, 8. If you take a decimal over here, 2.99. So you reduce A 8 power of 10. So let me raise it up to 8 power. So velocity of light can be very easily written in this way, and if you further simplify it, you find that this is nearly equal to 3, so it can be written as 3 into 10 power 8. And now we can very easily remember this quantity. This is scientific way to represent any quantity. So scientifically, you can represent any large quantity or any small quantity in this way. A is multiplied by x raised to power b. Now, next thing is order of magnitude. Order of one more thing, that when you consider this 8 power of 10, this is a very large number, and it is multiplied by 2 or 3 or 4, this becomes insignificant. So generally we ask what is the order of speed of light, what is the order of mass of electron or anything. We remember this order. So for order of magnitude, because remembering these numbers is not very necessary, because before this large number, this 2 is, this 3 is very insignificant. So next thing is order of magnitude. For order of magnitude, this A must be kept in between 0.5 and 5. Then you can find the order of magnitude. So here in this case, in velocity of light, speed of light, you find A into 10 power b. You find that here 3 lies in between 0.5 and 5. So what is the power of 10? You can take it as order of magnitude. So order of magnitude of speed of light is 8 only. This is one example. Now let us take another example. Mass of electron. Mass of electron is equal to 9.1 into 10 power minus 31 kg. And this is here in meter per second. Okay. So this cannot be your order. Minus 31 is not order. For changing it in order, we need to keep this A in between 0.5 and 5. Here we have A into 10 power B. So let me change this so that it can be made in between 0.5 and 5. Let me take the decimal on the left hand side. So when you reduce here the number of tens, you need to increase the power by 1, because you have reduced here. Okay. You brought here the decimal along its left hand side. You reduce the number by 10 times. So I have increased here in its power by 1. This is equal to 0.9 into 10 power minus 30 kg. So order of magnitude of mass of electron is equal to minus 30. So we must remember that for scientific representation of a number, this A should vary from 1 to 10. It is in between 1 to 10. 1 is smaller than or equal to A, and A is smaller than or equal to 10. But for finding order of magnitude, A must be in between 0.5 and 5. So there is a slight difference between order of magnitude and your scientific representation of any number. Slight difference. So do remember this. Next topic is significant figure. Significant figure very clearly state the accuracy and precision of any measurement. Now you have two new terms, accuracy and precision. We will be talking about the two things later. So first of all, you would like to make an understanding about what significant figure is. Suppose you have to measure the length of any object and you have placed this object along the length of a meter scale. Here you have in blue color meter scale and in red color you have object. You can see clearly that its one length falls on 0. Okay, one end falls on 0 of meter scale and other length is falling somewhere in between 13 to 14 centimeter. Okay, and it is in between the after third small division after 13. I have magnified this portion through a magnifying glass and I have taken that portion on this line. Okay, so in between 13 and 14 you have 10 divisions and this line falls in between the third division and the fourth division. So what the measurement that you can directly read from this measuring instrument is 13 point, it is falling somewhere in between 3 and 4. So this digit is very uncertain, the next digit. 13 you have directly noted from this meter scale, but now this digit is doubtful. You may write anything, either 3 or 4 or in between. So if you are looking from some side, though I have magnified this one and I have made this large, this distance very large, but it used to be very small. A millimeter distance is small. So some person may read it as 3, being along one side, and under his limitations, her limitations, he may read this as 3. So measurement is equal to 13.3 centimeter. But some other person doing the same thing from some other angle and under his limitation he may read the same thing as 13.4 centimeter. So what we see from here, that this last digit is uncertain. One last digit is uncertain and rest of the digits are certain as they are directly read from measuring instrument. So certain digits of measurement is 13. So you see that there is uncertainty in every measurement. Every measurement lead to some uncertainty. With its last digit is uncertain, not fixed, but rest of the digits are fixed. And significant figure is equal to a number of, okay, let me write, in a measurement is total number of all the certain digits plus one uncertain digit. Okay, let me change the color of pen. Okay. So here significant figure comes equal to 3. Now look what happens. If we, okay, here this stretch is equal to, this is stretch between 3 to 3rd to 4th small subdivision is equal to 1 millimeter. And this is called the least count of meter scale, the smallest length that can be measured from any, or smallest magnitude that can be obtained with the help of any measuring device is called its least count. So let me first of all write down least count. The smallest measurement that can be taken from a measuring device. Okay, so least count of meter scale. Equal to 1 millimeter. 1 millimeter. Okay. So you have down under this small stretch. So your measurement can be having from 13.3 up to 13.4. The maximum variations would be like this. So the main result can be in this way, should be written in this way, plus minus 0.1, means it can be either 13.4 or it can, if you subtract 13.4, if you subtract minus 0.1 from that, you can get 13.3. So a total stretch of your result, that variation of your result can be like this. So this much centimeter is your answer. Now your result can vary within this small subdivision which is called least count. So how can you make your result accurate and precise? Here, one way to make your result accurate and precise is to reduce this least count. Here you have least count 1 millimeter. What happens if you reduce this least count and make your least count 1/10 of millimeter, which is equal to 0.1 millimeter, and which used to be least count of a vernier calipers. Okay. So if you reduce the least count, then your measurement will be more accurate and more precise, because variation will be up to 1/10 of millimeter. So if you are measuring some length using Okay, the same length using your vernier calipers, then what will we got? You will got some another number like 13.42, because 1/10th of a millimeter is equal to 0.01 centimeter. So your measurement will last up to hundredth of your decimal point. So you will have 2 digits in decimal point. This much centimeter, and the result will vary plus minus 0.01 up to this much. So here you can see that number of significant figures is increased. Here in this very case, significant figure is equal to 4. So when significant figures increase in your measurement, then your result becomes more precise and more accurate. Okay. और हमने क्या देखा कि किसी भी मेजरमेंट में सारे डिजिट तो आपके सिग्निफिकेंट हैं, और एक जो लास्ट वाला जो डिजिट है दैट डिपेंड्स ऑन योर एस्टिमेशन, आपके अंदाजे पर डिपेंड करता है, ये वैरी करता है. तो इसको अनसर्टेन डिजिट को हम कहते हैं. दिस अनसर्टेन डिजिट, द राइटमोस्ट uncertain digit is least significant. And leftmost in a measurement is most significant. So significant figure is very essential thing that says about accuracy and precision of measurement. Okay. Now rule for significant figures. First rule, suppose you have measured, I will directly state the rules with the help of examples only. Suppose you have measurement 23 centimeter measurement. Here you have, and here you have significant figure. So the number of digits in this measurement is 2. 1 plus 1, 2. So significant figure is equal to 2. Now second case, suppose you have a digit which is equal to 230. Okay. So this is a measurement which has 0, which is containing 0. So in integral number, in integral part, you have not any decimal part, all this is your integral part. You will not count 0 as significant figure. You will have only significant figure 2. 1 plus 1, 2. Now suppose you take a decimal after integral part. So now 0 also becomes significant. Your significant figure becomes equal to 3. Now if you take some 0 just after decimal, then it also is a significant figure. Here you have significant figure 1, 2, 3, 4. 4, 1. If you have some non-zero digits just after 0 in decimal part, then all the non-zero digits along with 0 in between these non-zero digits, they all make significant figures. So just count the number of digits: 1, 2, 3, 4, 5, 6. So 6 is your significant figure. But if you have 0 in your integral part, and in decimal part after some 0 you have a non-zero digit, then these zeros are not making a significant figure. Here the significant figure only is 1. Okay, so these are some rules regarding the significant figure in any measurement. Significant figure in any measurement. Now, many a time we multiply with some number, like in measurement of diameter we multiply by 2 pi r 2. Many a time we multiply by 4, like for measurement of area we do area of a sphere, 4 pi r square. 4 is multiplied. So the number let me delete, which are multiplied or divided which are not measured, have significant figure, infinity. So this is all about significant figure, very important thing. It tells you about accuracy or precision of any measuring device. Okay, suppose you have measured one length using meter scale, and it is the result of measurement is given by 2.1 centimeter, and you don't know which instrument you have used or is used for measurement of length, and the same length is measured and by some other person, and the result given is 2.13 centimeter. Some other person has given the result 2.129 centimeter. So the same length measured by 3 different devices and it is measured up to millimeter. So the variation can be up to 1 millimeter. So you can plus and minus 0.1. And it is sure that least count of meter scale is 1 centimeter. So this first measurement is made by meter scale. This second measurement, which is up to 100th of centimeter. So this result must be written in this way, plus minus, because error will be up to the rightmost digit, and doubtful digit is only one doubtful digit. So if it is doubtful, so you must add and subtract 0.01 to get the scientific way. This is the scientific way how you will be writing the result, and this is done by vernier calipers. Now after that you have a screw gauge which measures up to thousands of centimeter. Means this result you can write in this way, plus minus 0.001 centimeter. So seeing the measurement, you have not been told that which are the measuring devices. You can immediately say, seeing the result, that it is the uncertain number is up to 10th of centimeter. So you can say that measuring device is meter scale. In this very case it is vernier calipers, and in the last one case it is your screw gauge. So this is all about significant figure.